Hi everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem count number of substrings. So first of all, let us start by understanding the questions. What does question say? Given a string of lowercase alphabets, count all possible substrings not necessarily distinct that have exactly k distinct characters. So basically we are given a string in which all the characters are lowercase alphabets, that is from small a to small z. We need to count all the substrings that have exactly k distinct characters. Okay, not more than k, not less than k. Okay, exactly k distinct characters. We need to return the count of such substrings. Okay, understand one thing, if a character number of distinct characters means how many different characters are present. So suppose I have a string a. So the number of characters is 3, but the number of distinct characters is only 1, that is a, because it is repeated 2 more times. Okay, so if we look at the example, suppose ABA is the input string and k equals to 2. So we need to return the number of substrings which have exactly 2 distinct characters. So one is AB, another is BA, because both of them have 2 distinct characters A and B, and the third one is ABA. It also has 2 distinct characters A and B. So the total number of such substring is 3. If we look at the second example, suppose the string is AB, AA, CA and k equals to 1. It means we need to return the count of substring with exactly one distinct character. So all the substrings which have one character, single character substrings will have one distinct character, that is A, B, A, C, A, B, A, C and A. But there is also one more substring, that is AA. AA has 2 characters but number of distinct character is 1, that is k equals to 1. So AA is also counted in our answer. There are no other substrings which have exactly one distinct character, so the output is 7. Okay, your task is to complete the function substring count, which takes the string s and an integer k as input and returns the number of substrings having exactly k distinct characters. Okay, the expected time complexity is big O of modulus s, that is length of string, and expected auxiliary space is constant, and the constraints are given here. So now if we think about solving this problem, then one of the brute force approach would be to calculate the number of distinct characters for all the substrings, that is n into n plus 1 by 2. If the length of the string is n, then the total number of substrings is n into n plus 1 by 2. So basically I count the number of distinct character for all these substrings. Okay, and whenever the number of distinct character becomes equal to k, I'll increment my answer counter. Okay, I'll start with answer equals to 0. So basically generate all the substrings and count the number of distinct characters for all substrings, and if whenever we get equals to k, we'll increment the answer because we got a substring which has exactly k distinct characters, right? Now this will take at least big O of n square time because there are n into n plus 1 by 2 substrings. Even if we consider that counting of distinct characters is a constant time thing, okay, we will see how we can count the number of distinct characters in a substring efficiently. But even if we consider that it is a constant time work, the time complexity would be big, at least big O of n square, because this many are the number of substrings, right? But the expected time complexity is big O of n, that is the length of the string. So we need to think of something more efficient, right? So now what we will do here is, see, counting the number of substrings which have exactly k distinct characters is difficult than counting the number of substrings which have at least k distinct characters. Okay, understand one thing. So if I tell you to count the number of substrings which have at least k distinct characters, then this would be easy work. Okay, here what we need to count? We need to count the number of substrings which have exactly k distinct characters. Okay, but counting the number of substrings which have at least k distinct characters is an easy task. How? We will look at here. Okay, but if this is an easy task, then what we can do? Our answer would be count of substrings, number of substrings with at least k distinct characters minus count of substrings with at least k plus 1 distinct characters. Did you got this point? I want to find the number of substrings with exactly k distinct characters. Okay, and what I said, counting of substrings with at least k distinct characters is easy work. So what I can say, number of substrings with at least k distinct characters. So what will be the substrings which I will get in it? I will get the count of the substrings which have k distinct characters plus count of substrings which have k plus 1 distinct characters plus count of substrings which have k plus 2 distinct characters, and so on. If from this I subtract the number of substrings having at least k plus 1 distinct characters, so I'll subtract the count of substrings having at least k plus 1 distinct characters. So what would it be? At least k plus 1 distinct characters plus k plus 2 distinct characters plus count of substrings with k plus 3 distinct characters, and so on. So basically this all part will get cancelled. So I'll get the count of substrings with exactly k distinct characters. I'll get my answer. So now we need to look how we can count the number of substrings with at least k distinct characters. Okay. Now understand one thing. Suppose this is the string that you are given. Okay. And you are considering this substring at present starting with L and ending with R. Okay. Now listen to my words carefully. Starting from index L, R is the first ending index. If I consider a substring starting with index L, R is the first index where the number of distinct characters is greater than equal to k. Okay, or it is equal to k. So what I am trying to say is that number of distinct characters from L to L, from L to L plus 1 up till from L to R minus 1, the number of distinct characters in this is less than k. The number of distinct characters from L to R equals to k. So R is the first ending index for starting index L, where the number of distinct characters in this substring is k. Okay. So if starting with index L, R is the first index such that this substring has k distinct characters, then can I say the substrings starting with L and ending at R have more than equal to k distinct characters? Yes. Can I say substring starting at index L and ending at index R plus 1 will have more than k distinct characters? Yes, because if this substring starting with L and ending at R has greater than equal to k distinct characters, adding one more character to the substring, that is R plus 1 index character, will either remain, the number of distinct characters will either remain same or the number of distinct characters will increase, right? So the number of distinct characters from L to R plus 1 is also greater than equal to k. The number of distinct characters from L to R plus 2 is also greater than equal to k. And so on, the number of distinct characters from L to N minus 1 is also greater than equal to k. So starting with index L, these are the substrings which have at least k distinct characters. Starting with index L, these many are the substrings which have at least k distinct characters, right? So can I say if starting with index L, R is the first index such that this substring has greater than equal to k distinct characters, then starting with L, the number of substrings with at least k distinct characters is how much? The ending index can be R, it can be R plus 1, it can be R plus 2, up to it can go to N minus 1. Okay, so it would be N minus 1 minus R plus 1, that is equal to N minus R. Did you got my point? Starting with index L, the number of substrings whose distinct character count is greater than equal to k is N minus R. And the substrings are L2R, L2R plus 1, L2R plus 2 up to L2N minus 1. Okay. Now, so we have got, starting with index L, we got the count of the substrings with at least k distinct characters. Okay. Now understand one thing. If starting with index L, R is the first index such that the count of the distinct characters in this substring is k, then starting with index L plus 1, the first index, the first ending index where the number of distinct characters will be greater than equal to k will be either R or more than R. If the substring from L to R has at least k distinct characters, but R is the first ending index to satisfy this, what does that mean? That the substring from L to R minus 1 had less than k distinct characters. Then can I also say the substring starting with L plus 1 and ending at R minus 1 will also have less than k distinct characters? Because if the substring starting with L and ending at R minus 1 has less than k distinct characters, and if I remove one character at Lth index, then my substring becomes starting with L plus 1 and ending at R minus 1. This will also have less than k distinct characters, right? So if we start at L plus 1th index, then the first ending index at which my count of distinct characters will be greater than equal to k will be either R or after R. It cannot be before R. Did you got my point? So we did two things. First of all, we understand this, that starting from L, if R is the first index where count of distinct character is k, then starting with L plus 1, the first ending index will be either R or greater than R, such that the count of distinct character is equal to k. Another thing is, if starting from L, R is the first index where the number of distinct characters is greater than equal to k, then starting with index L, the number of substrings whose count of distinct characters will be at least k will be n minus R. Okay, so now what we can do is, here L was this, okay, so we can vary our starting point from 0 to n minus 1, and for every index, considering that as the starting index, we can count the number of substrings starting with that index, L equals to 0, L equals to 1, L equals to 2, and so on. We can count the number of substrings which will have at least k number of characters, at least k number of distinct characters, and we will add them up, okay, and that will give us the number of substrings with at least k different characters. Similarly, considering the starting index as 0, then 1, then 2, varying our L from 0, 1, 2, 3, and so on, we can find the number of substrings which have at least k plus 1 characters and add them up. That will give us the total number of substrings with at least k plus 1 characters, and we will subtract them, right? And this will give us the total number of substrings with exactly k distinct characters. Okay, now let's understand that how, starting with index L, we can efficiently count the number of distinct characters. So now we said that we will keep changing our starting index, that is L, we will take it from 0, 1, 2, 3, and so on, and for every index considering at starting index, we will count the number of substrings that has at least k distinct characters. Okay, so what we can do is, we can start with L equals to R equals to 0. Okay, so if this is my string, this is my index 0, this is my first starting index. Okay, so suppose starting with this index, I'll keep incrementing R. I'll keep incrementing R until I do not get the count of distinct characters equals to k. Once I get it, I know that now the number of substrings, suppose this is R, then starting with L equals to 0, there are n minus R number of substrings with distinct characters count greater than equal to k, right? So I'll add n minus R to my answer. Okay, now I'll take L equals to 1, right? Now I want the count of substrings starting with L equals to 1 and whose count of distinct characters is greater than equal to k, which is at least k. So my R would be either here or more than that. So I will not take it backwards. I'll keep incrementing R until I do not get the count of distinct characters equal to k again. So it might be possible that when we increment L from 0 to 1, we may need to increment R, or we may not need to increment R. Okay, starting with L equals to 1, at this index only, at this R only, we may get the count of distinct characters as k, or we may need to add some more new characters because the character which was here may be missing, right? Suppose here it was A, then we had B, B, C, C, C. So the count of distinct characters was 3. Let's say k equals to 3. Now when L became 1, we are considering the substring this much only. Here the count of distinct character is 2. So I might need to add some more characters. Suppose here it is C and here it is A. So now starting with L equals to 1, this would be my first ending index where the count of distinct characters would be 3, that is B, C and A. Okay, but R will not reduce. So I'll keep incrementing L, and I'll also, for each L, I'll also keep incrementing R until the count of distinct characters is k. Okay, and then I'll add this to my answer. Now how will I maintain the count of distinct characters? So basically I'll take one array C of size 26, where C of 0 will represent the count of A in the current substring which I am considering, C of 1 will represent the count of B in the current substring, and C of 25 will represent the count of small z in the current substring which I am considering. whenever I am incrementing r, so I am taking a new character into consideration, I'll do C of S of r minus 97 plus plus. Okay, so basically if this is small a, then the ASCII value of small a is 97, so 97 minus 97 will be 0, so count of 0 will increase. Okay, and whenever I'll increment L, so I am going from L equals to 0 to 1. So first I'll decrease the count of the character at 0th index. So count of S of L minus 97, I'll do it minus minus, and then I'll increment the L. Okay, so the count of this character is reduced. Okay, so this array will be maintained. Now whenever we decrement the count of any character, if that becomes equal to 0, it means that now it is no longer present in the substring. So the number of distinct character will decrease by 1. I'll take one variable f to keep the count of distinct characters. So whenever the count becomes 0 after subtracting, we'll do f minus minus, that is the count of distinct character has reduced. Whenever we increment the count of a character and if that becomes equal to 1, it means that it is the first time introduced in this substring. So it adds up to the new distinct characters. It is introduced for the first time, so it is a new distinct character. So at that time I'll increment f. Okay, and every time I'll check whether f is less than k or greater than k or equal to k, and similarly I'll change the value of L and R. Okay, and we'll count the number of substrings starting with L, which has at least k distinct characters, and will move from L from 0 to n minus 1. Okay, and one more thing, what would be the time complexity? So basically the time complexity would be big O of n. Why? Because our L will go from 0 to n minus 1 and R will go from 0 to n minus 1 at max. There would be 2 loops, but 2 is constant, so I can say big O of n. And the auxiliary space would be big O of 1, because we are not using any new space here. Now let's look at its actual implementation, so that if you have any doubts, it will be cleared. So now if we look at the actual implementation, so as I said, what we will do, we will count the number of substrings with at least k distinct characters and subtract the count of substrings with at least k plus 1 distinct characters. Okay, and that will give us the count of substring with exactly k distinct characters. So what I have done is I have taken one variable answer initialized at 0, n as the length of the string, and answer equal to substrings with at least p number of distinct characters. This is the name of the function. So it basically counts the number of substrings with at least p distinct characters. Okay, and I have passed the string, the length of the string, and k in it, minus the number of substrings with at least p distinct characters, and I have passed the string and then k plus 1. So this will count the number of substrings with at least k distinct characters, and this will count number of substrings with at least k plus 1 distinct characters, and we subtract it and we get our answer and we'll return it. Okay, now if we look at this function, then this is the number of substrings with at least p distinct characters. Okay, so what I have passed in it, the string, the length of the string, and int p. So what I have done is, first of all, I have taken one flag variable f equals to 0, which will basically keep the count of number of distinct characters. I have taken one C array, and as I said, C of 0 will keep the count of small a, C of 1 will keep the count of small b, and so on. Okay, then I have made a loop from 0 to 26 and made the count equal to 0. Instead of L and R, I used L and R while explaining. Here I have taken I and J. So I is the starting index of a substring and J is the ending index of a substring. For I equals to 0 to n, I am changing the starting index. While the number of distinct characters is less than p, what I'll do, I'll keep incrementing J. So I'll keep making the substring bigger and bigger, so that my number of distinct characters becomes equal to p. Okay, so while j is less than n and f is less than p, increment the count of the jth character. Okay, and if that count equals to 1, it means that a new distinct character has come. So we'll increment the count of f and then go to the next value of j. If the number of distinct characters is greater than equal to p, so it might be possible that j became equal to n, but the number of distinct character is still less than p. Okay, so if it is greater than equal to p, then what I'll add to my answer, I'll add count equals to count plus n minus j plus 1. Okay, while explaining the concept, I said we will add n minus r. Here we are adding n minus j plus 1, right? Why? because when you consider the jth character, so suppose this is the ith character and this is the jth character, and for starting index I, j is the first index where my number of distinct characters became equal to p. Okay, but what is happening here is when I am incrementing the count of the character at j and incrementing f, after that I am also incrementing the value of j, right? So even if j is the first ending index for I, where the count of distinct character is p, when I will come out of the loop, my j will be equal to actually j plus 1. Okay, so that's why I here I have done n minus j plus 1. Okay, so this would be the number of substrings starting with index I, where the count of distinct characters is at least p. Okay, and then now my I will go to I plus 1, the starting index will change. So first of all, I'll subtract the count of the character at ith index, and if that becomes equal to 0, so that character has finished, so we will decrement the distinct characters, and finally I'll return the count, which is basically nothing but the number of substrings of string s, where the number of distinct characters is at least p. Okay, and in the function we subtracted the number of distinct substrings having at least k distinct characters. We subtracted the number of substrings having at least k plus 1 distinct characters, and that gave us the answer. Okay, so now let's submit this code. So let's submit it. So we have solved this problem successfully. I hope you understood the solution completely. Thank you.